Hi everyone and welcome to this new video in which I continue my Linux Privilege Escalation series. In this video in particular, I will show a specific attack called the Unshadow Attack that you can do anytime you have access to the shadow file in a Linux operating system. So the shadow file contains the hashes of the user accounts in the system, and the Unshadow Attack is all about getting those hashes and performing a brute force attack in order to crack those hashes. This in turn means that if you are able to successfully crack the hashes, you can get passwords for other accounts in the system. So if you get password for the root account, you are doing privilege escalation. Otherwise, if you get password for different accounts, you just do a lateral movement. But anyways, it is a useful technique to know anytime you have access to the shadow file. So this is an important technique to put into your toolset. So I hope the video is interesting and enjoyable. If you have any feedback, please leave it in the comments, subscribe to the channel, share the video with like-minded people, and that's it. You can enjoy the video. So as always, to start off, let's discuss the Docker setup. It's a simple Docker file, we can see it here. It just contains essentially the basic things with the username and some passwords. These passwords were chosen specifically to be able to be cracked, but in general, it's just a system with some tools. We don't really care about the tools, to be honest. So we can build the Docker. I've already done that, so there's no need to do it yourself. So we go into the content, we build the Docker. It's already been built, as you can see here. And then we can run the Docker with this. So we can say docker run. Now we have the Docker, and now we can just execute it a shell within the Docker. Now, anytime you are able to access the etc shadow file, which is this file, etc shadow, this is an important thing. Now, typically to access this file, you have to be root. So you can say, well, if to access this file I need to be root, what's the point of doing this? Anyways, sometimes it happens that the permissions are misconfigured or that there is a backup of the shadow file somewhere in the system. So it can happen that you are able to grab it, that you are able to somehow obtain it. And this technique, the Unshadow Attack, only works when you have these two files, the shadow and the Passwd. So these two files are needed in order to perform the Unshadow Attack. So what are these files for? Well, the idea here is that anytime we have to authenticate to the system, we must provide a secret for doing the authentication procedure. Consider a web server with a login form. You need to put your username and your password. This is an authenticator factor. It is proof that you are really that particular user. Now, in operating system like Linux, Windows, and also macOS and others, the idea is that within the system, we do not save the password directly. Also, this happens in databases of web server and web applications. So the idea is that you don't want to save your password in clear text. You don't want to save it directly onto the system. Instead, what you want to save is the hash of the password. It is something that you compute based on the password, but it is not the password itself. So the authentication procedure assumes that it has saved all the hashes within a file, and then to authenticate a particular user, the procedure does as follows. So to actually make sense of this procedure, we can just describe it really fast. So we have a saved HP, which is our hash of a password, and then we have the user credentials. So it is our username and password. So here I can just put text mode to remove this. So we have this thing. So the process does like this: check if username exists. So here I can just remove company mode actually. Check if username exists. If it does, compute h of password, and then check that h of p is equal to h of password. So you want to check that the hash you just computed on the new password, on the password that was just given to you by the user, is equal to the saved hash that is saved within a system file. So the idea of the shadow file is actually it is the file in the system that contains these hashes. And this file must exist. It exists both in Linux and in Windows. It's just that in Linux it's called a shadow file. In Windows it has a different name and a different location, but the idea is always the same. We save the hashes of passwords. For example, what is an hash? Well, consider for example the binary MD5sum, this binary MD5sum. So you can say, for example, echo hello, and then you pipe it into the program MD5sum, and here you have an hash of that particular string. And the cool thing about hashes is that even if I have, like, for example, hello with an 0 instead of an O, and I compute the hash, so like the input is kind of similar, right? However, if you check the output is going to be completely different. Now, there are various characteristics about hash functions. Specifically, the hash functions we use to save password are called cryptographically secure hash functions. They are crypto hash functions that have been studied by cryptography to have certain mathematical properties. We don't really care about those properties specifically in this video. We just want to show how to crack them in Linux. But the idea essentially is that they are resilient against different types of attacks. Now, specifically, MD5sum is not considered anymore a strong hash functions, a strong cryptographic hash functions. So there are, for example, SHA-256, 256 sum, this is a different one, or SHA-512, or this. And there are many different versions of these hash functions. There are a lot of different hash functions. The idea, however, is that these are saved within the /etc/shadow file in your distribution. And typically, the only user that can read those is the root user and the shadow group. So every member of the shadow group has read access to this particular file. Now, the other file of interest is the Passwd file. And if you check into our Ubuntu system, so now we are running into our container. So this is the container that we just created. So we can check etc passwd. So in the etc passwd, as you can see here, there are a lot of different metadata about the different accounts that are registered within the system. So for example, for each account, here you have the username, here you have the user ID, here I don't remember this other number, what it means, but essentially, for example, here you have the shell to use when you log in into the account. So here it's the path to the shell program that you want to execute when you do a login, an interactive login into that user. And here instead is the home directory of the user within the file system. So root as a home directory in the /root and as a shell of /bin/bash. There is a bunch of different service user, for example, www.data. This is the user we typically log in when we obtain a reverse shell within a web server, within a web application, after some kind of exploitation of a remote code execution. So that's the idea. And then we have Ubuntu, for example, is a different user. So it has UID of 1000. So this is the ID of the particular user. This is sort of like, I think, a name of the user. And then here it's the home directory of the user, /home/Ubuntu in lowercase. And once again, this is the shell process, the program that we want to execute when we want to obtain an interactive session with that user. And notice that for most of these users, actually, here we have a user/bin no login. So this means that we don't want an interactive shell when we log in into that user. Why? Because those users are not meant to be used interactively by people. Rather, they are meant to be service users. So you spawn a process and you give that process to the particular users. So like these users are just used to spawn different processes and to sort of like divide resources in order to decrease the attack surface, in order to implement a least privilege design within the system. So that's essentially the idea, so that if you compromise one account, like a www account, you're not compromising all the others. So that's a least privilege idea. I can talk about it in a later video. So the Passwd, however, notice that here there are no hashes. So this file can actually be read by anyone in the system, because if you check its permission, look, anyone can read it, others can read it. So this is readable by everyone. However, the shadow file, as we saw, is not readable by anyone. And why is this the case? This is the case because the shadow file, if we check its contents, we can see that this file actually contains the hash for that particular account. So here we have the hash for the account root, or the hash for the account Ubuntu. So the Unshadow attack essentially has to do with combining the information between the Passwd and the shadow file, and to crack those information with specific tools. So what's the idea here? So this is what I said essentially, Passwd. And so for example, how are these passwords being generated? This is interesting. Well, these passwords are generated with a specific version of the SHA-512 algorithm, of the SHA-512 hash function, which is called SHA-512 crypt. It is a more resilient construction that is more strong against brute force. So it's not just a basic SHA-512, it's sort of like same family, but different construction, different task function. So essentially that's the idea. So how we can we generate it? We can use the OpenSSL command. Now OpenSSL is a famous open source library that implements various cryptography. It is used, for example, to provide the TLS protocol to the various services such as Nginx, the various version of the TLS protocol. So here we are talking about HTTPS, so the secure version of HTTP. And notice here, we can put the OpenSSL, here you can say Passwd, so let's go into my system now, and then we can say this -6 is for the specific type of algorithm, I believe. Let's see if I remember well. Yes, -6 is for the SHA-512 base password algorithm, and then here we have the other arguments. So let's do a note here. So we do -salt. Here we put the salt. We can write 1, 2, 3, and then the new password. So like test password, and it's gonna generate a new password. Now notice that the password does not change if I don't change anything. So the function is deterministic. It's always computes the same value. However, if I change the salt just a little bit, here the hash is completely different. And notice that in this string, in the output that we see, there is the 6 to specify the type of hash. So it's like SHA-512 crypt. Then we find the salt, 1, 2, 3, and here is 1, 2, 3, 1, 2, 4. And then we find the actual hash value computed. And these dollars are just separating values that divide the various meta information, the various metadata. So why, by the way, do we need the salt? This could be an interesting discussion. And the idea is that if we don't have the salt, an attacker can just log in, can just get access to the hashes of the user, and he would be able to quickly identify what are the hashes that sort of like have the same password, which means what are the users that have the same password. Because if I don't put a salt here, I think it's gonna do it automatically. So in this case, it does it automatically. But let's say I put the same salt. Let's say the salt is 1, it's always 1. Well, notice that the hash does not change. So here I'm always getting the same output. So if an attacker essentially knows that the salt is the same and that the hash is the same, is also able to figure out that all those 3 hashes belong to the same password. They were computed starting from the same password. And this can leak critical information. Now, don't think about this simple example with 3 passwords. Think about the real data breaches, the real databases that have thousands, hundreds of thousands of records of users. And suppose that many people use the same password, say 100 of them, thousands of them have the same password. This sort of information leak can be really advantageous for like malicious actors, so that they can just focus on brute forcing the password which is the most present in the database, so they can just compare the various hashes. They see the one that appears the most in the database, and they just crack that. And by focusing their resource on a single hash cracking, they obtain the access to many different accounts. So the idea of salt comes in right at this moment. And the idea is that, okay, let's put something that changes for every user. This is called the salt. Now, the salt is stored within the hash, but we don't really care about that. The idea is that by putting something else in the computation, because now the computation is salt plus password even user who have the same password, their output will be different because the salt changes. So here we have salt, and then we have salt prime. The password can also be the same, but since the salt changes, these hash are gonna be different, they're not gonna be equal, so I don't really care even if I put the salt here, whatever. Now the attacker has lost any information about which are the hash that have the same password, that were computed from the same password. So that's essentially the idea. Now in practice, how do we deal with this? How do we crack these hashes? Well, to crack the hashes, we need a so-called word list typically. I mean, there are many different approaches, but one of the most simple one, we could say, is the one based on a word list. So a word list of different passwords. For example, one of the most famous word lists is the rockyou.txt word list. We can just download with this curl command. All of this will be in the description, so don't worry about that. So we can create a folder called new data. We can just curl the rockyou like this. We're taking this from GitHub. So it's going to take a while because it's a bit heavy. It's like, I believe, 100 megabytes or something of data. And this contains just a bunch of different passwords. So this is actually 50 because it's compressed. So let's uncompress it with tar. So let's uncompress it and then we check it again and we have 134 megabytes, so a bunch of different passwords. We can read the entire file. It's a bit large, but we can still read it. And I'm gonna activate so long mode. So long, okay. And as you can see here, there are a bunch of different passwords. Now these passwords were actually taken from real data breaches that happened in the past. So these strings were actually used by various users. Carlos, Jennifer, Bubbles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So as you can see, these are like pretty simple password. And we can go to the end. Till the end we see some weird characters, like some spaces. So like that's essentially the idea. Now this word list contains a lot of these passwords. For example, say that we want to just extract one password at random. We can just do the command shuffle with n1, rockyou.txt. Actually, I think it's shuff, the command shuff. And here we're gonna get one random password from the rock.txt file. So really, really interesting. Now, what is gonna be our approach to do this cracking? So essentially the idea is that we're gonna try all of these passwords, we're gonna compute the same hash function on all of them, and then we're gonna compare the output of the hash function with the hash saved in the shadow file. So this attack, as I said, can be done only if we have access to both the Passwd and shadow file. But what really is important is the shadow file, because the Passwd is really easy to obtain. So suppose you have access to both of these files in a specific distribution, in a specific target. So in our case, we're just gonna save them. So let's create, so I'm gonna do new data. Here I'm gonna create touch, shadow, touch, Passwd. I'm gonna remove the tar version. So I'm gonna fill those files for the shadow one. So I'm gonna do cat etc shadow. I'm gonna take all these text and I'm gonna copy in my local file. And this is one. And then I'm gonna do the same but with the passwd. So I open the passwd. I'm just gonna copy this output. So with the passwd, I copy this output. And now I have my two files of interest, the passwd and the shadow. Now at this point, a really useful utility comes into play, which is called the Unshadow utility. And you can install it with various ways depending on your operating system. I believe that the Unshadow utility comes when you install John the Ripper. We will talk about that later on. But essentially, assume that you have this Unshadow utility. I have it here. I do which Unshadow, user bin Unshadow. And if I do Unshadow help, I see essentially it's in John, it's a John utility. So it says usage, Unshadow, password file, shadow file. And here with password file, it means the passwd file. So the way you use it is Unshadow, passwd, shadow, and then you output this into a file and you call it Unshadow. So I did this, and now if you open the Unshadow, it sort of like combine the two different information together, and he put the hash taken from the shadow into the passwd in a way that fill the gaps essentially. Because in the passwd here, we do not really have the hash. Here we just have a bunch of x's, x, etc. And now though in the Unshadow file, we actually see the hash. So we actually see the hash of the users. So that's the first step. The second step is to use a password cracker. Now there are many different password crackers. The most famous ones are John the Ripper and Hashcat. They are complex tools that allow you to perform various types of attack, all based on the idea of cracking hashes. So the idea is that they can work in different ways. The way we're gonna work with it is using the rockyou.txt word list. So we install, for example, John the Ripper, and we do, the command is like this: John -- format equal crypt. So this tells John the Ripper that, look, the hash we want to crack is a SHA-512 crypt version. Then we pass the word list, so all the passwords that we want to try on, and then we pass the unshadowed file. So we can just do this command here. So I think it's in the other shell here. Okay, we have the new data, we have the unshadow, so we have the unshadow here, and we have the rockyou.txt, so we have everything we need. We launch the command, and in a bit, for example, is able to crack immediately the first password, which is the password for the user Ubuntu, and the password value is ABC123. Now this is the first user, of course. Now notice that in the Docker file, the second password is this LPRULZ4E, and if you actually check if it's present in the rockyou, I think we might find it, because I created them specifically. So let's do cat rockyou grep for this thing. And notice that we do get a match, which means that this thing actually exists in the rockyou.txt file. So at some point is the tool we just launched here is gonna find also the second password for the root user. But of course, the question of how much time it takes depends on your processing power, sometimes also your GPUs, because sometimes you can just parallelize this kind of computation effort. And also it depends on how far is within the rockyou.txt word list. If it's at the end or at the beginning or in the middle, it can take also between like 10, 15, 20, 30 minutes, sometimes 1 hour. I mean, it mostly depends also on how like much processing power you have. Here I'm running with a 10-year-old PC, so it's not that fast in terms of CPU. But still, the first password, since it was among the first entries, it immediately cracked, and it's the password of Ubuntu. So essentially, this is the main idea. Now, in our system, we can just, like, let's say that we log into a different account. I mean, I'm root right now. Let's say that we log into the www data. I mean, this account is not available, so what if I do su Ubuntu? And then I do sudo su, and it asks me the password for Ubuntu. I press ABC123. And now essentially I'm in root again, but I had to authenticate to Ubuntu. So for example, I can also do passwd, current password ABC123, and now I can put a new password. So when I put a new password, of course, the hash in the shadow file is gonna change accordingly, because I have a different hash since I authenticate with a different password. So essentially, that's the main idea. Now you can either do it with John the Ripper or with Hashcat. However, when I was preparing for this video, I had some problem using Hashcat because it was like, essentially gave me this error. I'm gonna show you. I think it has to do with either my configuration or something like it's not able to read the various passwords, token length exception. I was not able to debug it, so I just used John the Ripper. If you know how to debug it, it would be cool to just write in the comments. I mean, I'm running with Ubuntu, with an Arch Linux distribution on an x86-64 thing. So I'm not sure if it's maybe the version. I mean, the Hashcat version that I'm running on is the 626. But essentially, you can also do it with Hashcat. But the thing with Hashcat is that I had this bug, so I couldn't really test it out dynamically. So this is it for this unshadow technique. It's actually pretty simple. It's all about cracking hashes. To do this technique, we must be able to read the shadow file. So suppose you have access to a Linux system, suppose you are able to read the shadow file, then you can try to crack the hashes. Sometimes this is an important step to do, at least maybe one day. Like, it depends of course on why you need to crack that hash, but it can still be a way to approach doing privilege escalation. It's not really that amazing, it's not really that fun to do, but it's an important knowledge to have in your toolkit for doing Linux privilege escalation. So this is it for this video. I hope it was interesting, it was enjoyable, I hope you got something out of it. If you did, please let me know, write in the comments, subscribe to the channel, help me grow here on YouTube, and see you to the next video.